do it. Okay. How's that? How? Right. It's amazing what you can do with technology today, right? The weird thing is that when you stop and think about, like, all of this stuff is built on the same things that everything else is built on. Like, it's all JavaScript. So like everything in Google Meet and everything in the slides and docs and everything, it's just all built on the same stuff. So
I wasn't even exposed to JavaScript until like last semester. So like my coding, I didn't even really know what coding was until college. If I come to college and I see code on the board, I'm like, I have no idea what any of this is and how any of this works. So like this is like literally learning an entire new language to me. And then I'm like, okay, there's more than one language than Python. So that's another class for me. And I recently had a front-end development class this past semester, and I was like, oh, JavaScript is a thing. Didn't know what that was. So like this whole exposure to everything, being in college, the curriculum is always a little bit behind. So I come to Twitter, I'm like, these people are doing things that I've never even heard of. So that's another reason.
Are you a computer science major in college?
I'm actually a cybersecurity major, which is interesting because it has nothing to do with front-end web development when people think of cybersecurity. But I was like, I enjoy making websites. Why not just learn in my free time before I go off into the workforce?
I see. That makes a lot of sense. And college is like, having worked in a college for a long time, they don't teach the cutting edge stuff. But I think if you think about that, the cutting edge is only cutting edge for like a minute, right? So then there's the next thing. When I was first teaching web development, jQuery was like the new hotness, and everybody was jQuery. And if you weren't using jQuery, you weren't anything, right? Now nobody uses jQuery, or it's still out there. It's just not nearly as popular as it used to be. So trying to keep up with that and trying to build the curriculum for that and everything, like the fundamentals don't change. The fundamentals, like arrays have been arrays for 40 years, 50 years. So they're not remarkably different today in JavaScript than they were years ago in C. We'll talk a little bit about. They are remarkably different than they are in C, but concepts are the same. So let's move on. So you know what an array is. Like, variables by themselves, really simple. Like a variable is just one thing. It can be an object. It can be a couple of different things. But like you're referring to one thing out there in your memory somewhere. So your computer has all this memory. It's storing all this stuff. Something like a string, like John, is probably going to be a couple of characters in memory somewhere. A simple number is just going to probably be just a couple of bytes of memory somewhere. So all of these things are just one thing. But when you get into an array is like a block of adjacent variables. So like, think of it like you have a big, long, block of your memory, where you can store different things. And arrays have a couple of weirdnesses, right? So it's basically this contiguous block of memory. So you reference each value in an array by these indices, these 0, 1, 2, 3, 4, 5, 6. An array has a particular length, which in some languages is not so set. In some languages is a little bit more static. It's a little bit more, it's constant from the time you create it. And they have all these elements. So an array has different elements, and they go, it may be numbers, it may be characters, it may be strings, it may be objects. It could be a whole lot of different things. But if you look at the real, like, what an array is an array is randomly accessed. That's like a really important quality of an array. That's why we need arrays, because if you have some data structures, you may only be able to access the end of it or the beginning of it. With an array, you can go anywhere into it and you can access values. So that's a pretty important property, because I can just set something new in the array. I can just get a value from the array, and I don't have to worry about how difficult or how computationally intensive it is to go to that place. And different data structures do that differently, So that's the reason why we build a lot of things with arrays is because they have that nice property. I can have a lot of variables, but I can also kind of look at it and pick one out from the middle pretty easily. Arrays are also ordered, so they have a particular order. It's not like, if I go to position 3 in the array, if I go to index 3, that thing is that thing. Unless I change it, it's always going to be that thing. It's not going to be something different. In other data structures, that's not necessarily a property, So some data structures I might set, it may not have a set order. If I add something new to it, it may change the entire order of the whole thing. So arrays being ordered means that I can kind of depend on the way I put it in there is the way it's going to be. So I can, that quality alone is pretty important. And the fact that they're contiguous is, there's one after another, which makes things complicated later, right? If I want to remove a value from an array, I can't just have a blank space in it. It's got to, we have to do something to close up that blank space. In some languages, the array is, like if you look at Java or C++, everything in the array is probably the same type of thing. It may be, like a subclass of something else when you get into objects, but like generally they're all objects, or they're all integers, or they're all characters, they're all bytes, or, it's all the same kind of thing. JavaScript lets you put anything in any position in an array. It doesn't really. Yeah.
Like my first exposure to data structures was actually Java and like data structures and algorithms. Totally bombed it the first time because I was like, I have no idea what this professor is saying. So I was like, I'm gonna retake it because the second time I'm like, okay, I need to rethink my career. But I retook it and I actually passed. I was like, okay, I think I kind of understand it. So this is definitely making sense. It's more of like a memory bringer.
Yeah, good. Well, good. I hope it's helping, and feel free to interrupt me anytime because I tend to monologue and I can go on a long, long time. So,
okay, no problem.
But I will tell you on that note, I took data structures in college and I didn't understand most of it. I knew some of the pieces and I could do some of the things, but like I couldn't explain how to write out these different structures. I couldn't explain how they work. I could barely even tell you what they were good for. And fortunately, I got a job not long after I graduated where somebody kind of showed me how these things work and explained why they were important. And that's when I took it on, but I didn't really even understand it till I started teaching it, so I think data structures, the thing about data structures that's weird is like you learn a language, you learn the control structures, you learn your if else, you learn loops, you learn how the objects work, you learn how to write a program, you learn functions, you learn everything about it, right? And you think, okay, I can solve anything. And then it turns out there's this like whole world of like, how do I solve these really complex, difficult problems? And that's where data structures come in. And I think that the interesting thing from a instructor's standpoint is like, I get students come in and they're like, I know everything about programming. You're not going to teach me anything. And then by the time you get into the third week and you're talking about linked lists, they're like, I don't know. Like I'm changing my major. I don't know anything.
Yeah.
So it's pretty common. You're in good company, I think.
Yeah, it's that honestly, I already told my professor, I was like, sir, like I've never programmed before. So you are going to take all the patience you have ever had in your entire life and use it with me. Cause this is like, you gotta literally a beginner. Cause sometimes it's kind of, honestly, it feels weird, but it's more of a rarity for someone to come into college not knowing what programming already is. Usually the students I meet, they're like, yeah, I've been programming since I came out the womb or something like that.
Yeah, I think that's pretty common where some people are just, they've been doing it forever. But that does, I talk to a lot of people. I've had students the first time they've ever written code was in my class. So, it takes a lot of different kinds, but it's tough. Data structures, it's the first time where you have to kind of trust the computer is going to do what it's going to do. Every time up until then, every single thing you want to do in your program, it's direct. It's very imperative. Like do this thing, access this value, change this variable. When you get into data structures, especially like the first time you look at a linked list, you're now you're accessing things you don't like. It's through so many layers. It's through so many pieces. It's just as hard to wrap your head around it. So totally understand. All right. So arrays are good for anytime we need to create a bunch of things and we need to reference them as one. So that's why we use arrays a lot for algorithms, because a lot of times like we want to sort something, or we want to find out what the largest element in an array is, or we want to organize things in a particular way. Arrays allow us to keep track of all of that. So when we do examples, like sometimes the examples are like, it's like fruit, right? Well, I'm probably never going to have a practical situation where I need to identify apples, bananas, cherries, and dates in my program. But numbers and like organization or, human resource records, like all of these things have practical value in business. So the array allows you to kind of treat these things the same. If I have 4 variables that are separate, I can write a little bit of code and I can tell you what the smallest or the largest one of them is. But that's kind of hard with 4 variables. If I have 12 variables that are all independent, that gets harder and harder. So like an array allows you to kind of generalize that problem so that I can always run the same kind of solution. Because if I have an array and I know it starts at 0 and I know it goes up to array.length -1, I can always kind of write a solution that's going to iterate through that array using a for loop or something. So that's why, arrays can be really practical and useful because they allow me to take a problem solution and apply it to any size problem, as opposed to something where I might have to rewrite my code every time I have to encounter a new size of problem.
That makes sense.
So we call the values that we access an array with indices. So, we create this array and it may or may not be full of values, but anytime we want to access one, we use an index. So usually if you create an array of of size 4 or 5, 4, you're going to have index 0, index 1, index 2, index 3. A really important thing to think about is you never have the length of the array as an index. Except in JavaScript. It is okay in JavaScript. You can pull it off in JavaScript. JavaScript gets a little weird with it, but we'll get into that in a couple of slides. JavaScript allows you to just add things to your array because in JavaScript, everything is an object. So adding new things, it just adapts reasonably well in most situations. That's one of the things that makes JavaScript really easy, but it's also one of the things that makes JavaScript really hard because you can just do things you can't do in other languages and it'll let you do it. But sometimes that causes problems when you're trying to solve bigger and bigger problems.
Okay.
But, for example, if I were in Java or C++ and I created an array that was size 4 and I accessed index 4 in that array, I'd get an index out of bounds exception. I'd get some kind of error because that's not within the array. An index or an array of size 4 is going to have 0, 1, 2, and 3, but it won't have 4 unless I make the array bigger. So in Java and C++ and some other languages, you can't just access the value. JavaScript will just figure it out for you. In Visual Basic, way back when Visual Basic was popular, it started arrays with 1. So that caused all kinds of confusion because instead of 0, 1, 2, 3, it was 1, 2, 3, 4. So that rule wasn't really applying there either. But I don't know that anybody writes a lot of Visual Basic code these days. So it's probably not something you have to worry about too much.
No, I think one time I saw a position open for Visual Basics at my school. I don't think anybody applied.
I spent a little bit of time writing Visual Basic, a little bit.
All right.
Yeah, it's not my favorite language. So length will always tell you the size of the array. And this is a really useful thing to be able to do because, like I said, you can generalize your solution so that you just iterate through the array. And since you know where length is, you always know where the end of the array is. So in a for loop, like if you use a traditional for loop like for var I or let I equal 0, I is less than array.length, I++, that allows you to iterate through the entire array with no real worry that you're going to go out of bounds just based on looking at the array. So that's one of the reasons why we use arrays for a lot of things, because the language is actually sort of structured to work with them really well. Adding values to arrays, in JavaScript, you can create an array just by using brackets. Like I can say, let x equal 2 brackets, open, close bracket, that's an array. I can also use let x equal new array, and that works too. I can also create several values and initialize the array that way. So you can create arrays a couple of ways in JavaScript. But you can also just add, you can add your indices just like this. So one thing you'll see in this first example is, well, 2 things you'll see. One is it says logger.log, which I wrote these slides originally for AppScript, which is a little bit different than JavaScript. It's mostly the same thing, but AppScript is like if you're writing functions for Google Sheets or Google Docs. So AppScript works there. If you know JavaScript, AppScript is like this for you. It's like nothing, so it's really easy. But think of logger.log like console.log, works the exact same way. But in the first example, we just create a new array, and then we just start adding values to it. X0 is 20, X1 is 22. We didn't say it needed to be two elements wide. We didn't set a size or anything. We just said, give me an array.
Right. I was just going to say that. I was like, you didn't have to set a length of the array at all. No,
you don't have to set a length at all in JavaScript. You can just start adding values. Though the more typical way in JavaScript that you see people add values is this push method. So they, instead of using, just the index, push allows you to add values to the end of the array. The nice thing about push, when you look at these 2 examples here, is that you don't have to remember what the index is. Push just always adds it to the end of the array. And push is actually, computationally, it's pretty efficient in JavaScript because it's just adding to the end. So, you're just growing the array by 1 value. And that's that's pretty, it's pretty unique to Python and JavaScript. Some other languages have this kind of dynamic array by default, but JavaScript and Python both have this, I just add a value, I just keep pushing values or adding values to the array, and it'll keep appending them and resize the array appropriately. So in some languages, though, that's super weird. It's like a really bizarre thing, because in Java and C++, once I create the array is the array. I can create a new array, and I can assign that to my variable, but I can never change the size of the array. The size of the array is always the same. So that's a really useful property in JavaScript, but it also makes a couple of things more difficult. For example, I never really know what the backing implementation of an array is. I don't know if it's like actually like an array in C++ or Java. It may be more of like a linked list. It may be, a dynamic array. I can't really predict its behavior super well. And if you think about that, that's like a really weird thing. I always throw a little history into my computer science. JavaScript's been around for 26 years now. Almost 26 years. So JavaScript has had some time. And when JavaScript first came out, you couldn't really guess where it was going to be run. It could be run in Netscape. It could be run in Internet Explorer. It could be run, there were all these different browsers available. So how JavaScript operated was really hard to predict. In Java, if I have an array, I kind of know what I'm going to get out of it. In fact, in C++, most of the older languages, I know what's happening when I do something. In JavaScript, you don't know. You don't know what's behind that array. You know how it's going to behave, but you don't know how computationally efficient it will be. You don't know what it's really been optimized for. Python, even, you kind of know what the implementation of Python is. You know how it's going to work. It's pretty predictable. JavaScript, even today, JavaScript may run in your browser, and there are 3 or 4 different browsers out there. It may run on a backend server somewhere. There's some variability in how it actually operates. So this is something that makes JavaScript a little bit of a challenge sometimes, because certain things you can do seem really easy, but they take a lot of processing cycles. So if you think about this, at some level, they have to have somewhere where this data is stored, in JavaScript. So if I have an array that's like a Java array and it's 7 elements, what happens when I want to add that 8th element to it?
You're going to, in JavaScript or Java?
If assume you're writing the JavaScript language, so you're trying to figure out how an array works. So if you have 7 positions, what happens when you have to add that 8th value to your array?
I'm assuming you have to get a bigger array to add those values.
You got it. That's exactly it. So you have to get a bigger array. You have to put those values into that bigger array. So now you have to take the time to create that new array, which is going to take some time. You have to take the time to copy all of those things into the new array, which is also going to take some time. So that little operation of just adding a value to an array, suddenly it's this bigger operation that takes a lot of time. And then it could be a linked list, in which case you don't really know what's going on, because you have to figure out where it's going to be added, and so it could be a lot of different complication there, and you also don't know how quickly it's going to grow. Like, how much is it going to grow? So I might go from, if I'm writing this myself, I might take it from 7 to 15 or 7 to 14, or I might go from 15 to 30. Like, I might double its size every time, but it might only go up by 20% or 10%. So how do you try to, if I know I'm going to put 300 things into it, how do I make sure that I'm doing it the right way so that I can, optimize the code so it runs efficiently? So I reduce the number of times I have to resize it and add everything back to it.
This is sounding more like big O notation and making sure, I guess it's space and time complexity, which I heard of, somewhat remember.
So yeah, that's exactly it. You've got it exactly. So if I'm adding a value to an array and I need to resize it, that's actually big O of n, where n is the number of things in the array. If I don't have to resize it, that's big O of 1. It doesn't really take much time at all. But yeah, this is where the big O complexity comes in. It's not, big O doesn't really mean anything on a practical level. It just allows you to think in terms of how hard is this? Like, how much processor time does it take? How long or how difficult is it to execute this operation? And I think one of the, abstraction is one of the greatest things in computer science. Abstraction is basically this idea that I can take somebody else's code and I can call some functions and it just works super well. So I don't have to think about how the bits are going to be manipulated on the hard drive, right? That's not something I have to consider. But it's also very dangerous, because I might be doing some of these things that seem really easy and it could just be really, really computationally intensive.
Right. So
you run into this problem where you can do things really quickly and easily, but who knows? You might be calling up an entire data center to execute your little operation. And that's kind of the give and take of abstraction.
Okay.
So removing values from arrays in JavaScript, you use the pop method. You can just remove the last value in an array. Just takes the last value right off of there. You can also use shift. So JavaScript has this shift and unshift that allow you to take values away from the beginning or other places in the array. The reason why it's called push and pop is actually because one of the oldest data structures in computer science is called a stack. And a stack doesn't, I don't know why they didn't just call it add or remove. I don't know why. I don't really understand why the words are the way they are. But when you add a value to a stack, they say you push something onto the stack. And when you take something off of the stack, they say you pop things off of the stack. So a real stack really only has 3 or 4 operations. It has a push where we put something on top of it. It has a pop where we take something off of it. We have it's a peek where we look at the thing that's on the top, and it has a size. Maybe that's implemented. It's really not that hard to provide if you're writing that stack data structure. So sometimes you call a stack a last in first out queue, a LIFO queue. The last thing you put on is the first thing that comes off. So you add things to the stack. You take something off the stack, you add things to the stack, you take something off, take something off, take something off. So when I was in college, they always used a metaphor of plates and how you can always put a plate on the top and you can take a plate off the bottom or take a plate off of the top. But I always thought that was kind of dumb because I was like, you can move a plate, right? You can lift it up and put it in the middle. But if you think about it, like you need to see the designs on a plate and you're looking face down at the plate, you kind of think of it like this makes it make a little bit more sense. Like if you look down on the plate and every plate has a different design, you can only see that design that's on the top plate. So if I take that off, I can take that top plate off and see the next design. And if I put another plate on, I can see that one, but I can never really see past that. This seems like it's really restrictive and may not have a lot of value, but stacks come up a lot in algorithms. We need to put things on a stack so that we can deal with them later. And probably the most common use of a stack is when you are, when you're writing code and you're in a function and that function calls another function and then that function calls another function and that function calls another function. The program knows when those functions are done to come back and everything just works. So what happens is you take all of the things that are going on in that function and you put them on a stack and then you go into the next function. And then it takes those things and puts them on a stack so that when you exit those functions, it just takes things back off of the stack so that you resume operating just like you would expect.
This sounds like recursiveness to me. My head's
Stacks are used a lot in recursion, and I think that sometimes you can simulate most solutions are really easily translatable between recursion or iteration. So like recursion where I am calling the same function over and over again, or iteration where I'm repeating the same operation. So with a stack, you can often simulate what's happening with recursion.
Okay.
So it's a little bit complicated, but if we keep going and we look at like trees, some of the things you might do with a tree, you can use recursion or you can use a stack and just iterate through a solution. So stacks are actually pretty common in a lot of data structures. A lot of data structures are just built out of smaller data structures in some way or another. So that's why stacks come up, and that's why it's called push and pop. And that's why it's also, you can take an array in JavaScript and you can use it just like a stack if you only access push pop. And I don't know if there's a JavaScript peek method. I never looked at it, but
I'm not sure. I'm still on like variables and loops, and then I got confused when we got to functions because I was like putting functions inside of a function, and it was just a lot of stuff going on.
Yeah. JavaScript can be hard for that. So recursion, I'm happy to talk to you about recursion sometime in the future if you want to go over some examples there, because recursion gets pretty hard to get your head around, but it also can be pretty efficient and it's a pretty intuitive way to understand certain kinds of problems. All right, so unshift, you can unshift to add values to the beginning of an array. And there's a lot of other things you can do with an array as well. But this is where some of that complication comes in. When you unshift values, when you add to the end of the array, nothing has to move. You're just putting a value in at that array. You may have to resize it. You may have to add new things to it. So adding at the end is really not that big of a deal. Removing from the end is also not that big of a deal.
At the beginning, it's difficult because now you got to shift all your values over.
You got it. So unshift may seem like a really simple operation, but every single time you call unshift, you're moving every value over to make space for it. So that's where the computational complexity comes in here. Unshift is going to be a big O of n operation because I have to move n things every single time I call it. So reverse is also another one that looks really simple, but reverse is also a big O of n operation because now I have to create a new array and I have to copy everything into it the opposite way. So, reverse seems simple, but again, it's a little bit more expensive than it might look originally. And usually big O of n isn't that big of a deal unless you get into, hundreds of thousands of elements or millions of elements. And then suddenly that's a much more significant cost. The reality is nowadays that your processor can do more than a billion things in a second. Like it's really capable. But if you have to reverse a billion things, your operation is going to take a second. And I think that the thing where this really comes in importantly is if I'm running a server, if I'm hosting my own website and something takes 7 milliseconds, but I'm getting a request every 6 milliseconds, I'm going to get behind, and eventually that's going to cause problems for me. So efficiency is really important still. The other thing that it really comes into is power usage, and that's not something that people thought about 30 years ago, or maybe they did, but it wasn't quite so much of a consideration. But now, the less efficient your code is, the more power it uses. And the more power it uses, if you're paying for cloud hosting, the more expensive it's going to be. So, it's another reason why you might want to try to make your code super efficient if you can. All right. So, again, JavaScript arrays are more flexible and capable, but that does come with a cost. You don't really know necessarily how costly some of these operations are going to be, but you can pretty much assume that shift and unshift are going to be more expensive than pop and push. So a better way to kind of handle that is to think about, how you're trying to solve this problem. And it seems like a small thing, but adding values at the end is so much cheaper computationally than adding values at the beginning. So if you can solve your problems in a way where you're looking at the end of it versus the beginning, you can actually get a lot of efficiency out of your code. So shift and unshift take up a lot of processing cycles. And like you said, you have to move everything. So anytime we add a value, and if we remove a value, we still have to move everything over because we can't just have that empty space. And, I had a lot of trouble with that when I first started computer science. Like, why can't you just leave the empty value there? Just ignore it the next time. But now you got to write code to ignore it every single time. And the next person has to write code to ignore it every single time. And it just gets very costly to, like if you think about the computational cost is small, compared to the number of people who have to now accommodate all these weird empty spaces in your array.
Yeah.
So that's where it comes back. You can do a lot of things with the JavaScript array, though. JavaScript arrays, I got a slide coming up that just talks about, there's a lot of different capabilities. Most languages, an array is basically a variable and a length, and that's it. Like, it has nothing else other than that. But in JavaScript, you get all these nice, useful functions. So you can convert an array to a string. So you can just basically concatenate everything together as seen here. You can also use join to join an array together with a particular value. So we can create a string out of the array by using join. And here you can see this would actually contain W_O_R. So this can speed up your coding. Again, these operations they're not gonna come for free, but as far as simplicity of your code, it's really nice because now I can look at values.join and I kind of understand what that does instead of having the 7 or 8 lines of code where I'd have to create a new string and I'd have to append every character and I'd have to append the join character. That could be harder to understand, harder to read, and more code to maintain. So there are values to having sort of the terseness, to your code here. Split is also a thing you can do with a string that will convert it to an array. So that's kind of the reverse of join. If you have this split, you can now take something out. So one thing you could do is, instead of trying to replace everything in an array or replace everything in a string, you could split it apart based on that thing, and then you could join it back together without that. So, you could kind of you could take out some value and get several strings and, using a split and then a join right away. Really simple code. Again, not trivial execution, but the code is really simple, so it's really easy to understand. Understandable code is super valuable. The number one problem that you'll run into in computer science over time is maintainability. You write the code for a while, you write the keystrokes, you launch the code, it's going to operate a lot longer than the time it took you to write it. It's going to go on for a long time. So when a problem arises, having to go back into it, understand what was going on, try to read it, try to fix that problem, that maintenance is going to cost you a lot more than writing the keystrokes ever will. So writing understandable code is probably at least as important as writing code that's reasonably performs reasonably well, reasonably efficient. So we can also determine if something is an array. JavaScript is, as JavaScript has data typing in JavaScript is weird. Just to kind of put it pretty simply, it's not always super easy to identify what something is. There's some auto conversion in certain ways. JavaScript tries to make some smart decisions on what it does. Like adding to a string concatenates, but subtracting to a string sometimes converts it in a weird way that you don't expect. So sometimes checking what something is useful. So we have the instance of operator in JavaScript that we can use to identify if something is an array. You can also use array.isArray, and that will tell you if something is an array.
Don't mind me, I'm just writing.
No, yeah, hey.
All right.
And then there's a lot of different operations on arrays in JavaScript. You can change them to strings. You can join them together. You can do the pop, push, shift, unshift. You can use splice to insert values inside of an array. Again, easy but dangerous, but also really simple in your coding, so it can have some value there. You can concatenate an array, so you can basically take one array and add it to a second array. So, if you think about what has to happen there computationally, you still have to create a bigger array. You still have to copy the values in, but, it makes it really easy to take two arrays and join them together. You can take slices out of an array, so you can take subsets of the array. You can get the entries in an array, and you can iterate over that using like a JavaScript for each loop. You can use a fill to fill an array in with different values. You can use a for each to iterate over the different values in the array. You can use index of to find things in an array. And this is one that's really interesting too. I probably should have had a whole slide on just index of, because it's a similar kind of situation where it looks really easy, but it might be a little more challenging. So index of will allow you to find something in an array. So like if I have an array full of numbers and I use index of, and I give it a number, it will tell me what the index of that particular value is. Well, there is a problem there. Do you know what the problem is? The challenge that I run into when I try to use this?
I'm not sure.
So it kind of works the same way as these other operations. If I want to find something in an array, I have to look at every element in the array. So, let's say I've got an array full of numbers and I use index of 17. Well, now I have to look at all of the numbers to see if 17 is there. And I can finish as soon as I find it, but it's going to be a big then operation. It's going to take as many things as are in the array, because I might have to look at the entire array. So index of seems like it's really simple, but it might have to look through the entire.
The index of a number or a string or whatever I'm looking for.
Yeah, exactly.
So it's through there. Okay, I understand.
Yeah, and it's telling me where it is, which is, again, the code is really simple. It looks like it's easy to understand what's going on there, but you have to find it. So looking at every element, if you did that over and over and over again, it could really slow down your code. There are better ways to do it when you get into algorithms. Like you can use a binary search if your data is sorted. So if the array is sorted, you can use a binary search to look at the middle and then look at half of that array and then look at half of what's left and half of what's left. You can keep doing that, but the challenge, like you have to have your data sorted, which doesn't happen for free. You can use the sort function. There is a sort function, but again, that takes some time for the array to actually sort. So lots of different things you can do with JavaScript arrays, but you can build these arrays if you have an array, and typically you see this in languages that have more like a true but limited array. You can build a stack, which we already talked about. Like a stack is a data structure where you put things on one side, you take them off that same side. So it's generally a pretty efficient data structure. You can build a queue with an array, and in JavaScript you can do this pretty easily. You could just use pop to take things off, and you could use the shift or unshift to I think it's unshifted to add them on. So that way you could build a queue, but it would not be super efficient, right? Because every time you add something, it's going to be costly to taking them off would be easy, but adding things would be costly.
So it's like, I can't remember the word. I think it's like DQ and then I don't know if it's unqueue or NQ.
NQ, you got it. So those are your terms for data structure for a queue. I don't know why all of these things aren't called the same thing. I don't know why when they were coming up with them, they didn't just come up with the same names for everything. Because like add and remove are really simple words to me that are pretty flexible, but nobody asked me when they invented a queue, which was probably hundreds of years before code was a thing anyway. So, but queues, yeah. So a queue you take off of one side, you add to the other side. So if you think about that, a queue is really good if you need to like put together like a time priority of things. When I add things, the first thing I add in is going to be the first thing I take out. If I need to mimic a line, for example, or if I have a bunch of tasks that are going to take a lot of time to execute, I might put those tasks in a queue and then just execute them one by one. So queues are pretty common. When you get into some data structures, you see them used for different problem-solving techniques. Dynamic arrays are actually what you get in JavaScript, so and in Python. A dynamic array is basically something where I can access any value in it. I have that random access. I can put values into it anywhere, but they grow as I need them to grow. In order to do that, really all they have to do is when you add values to it, you just have to make sure that it's not too much data. And if it's too much data, you just grow the size of your array, which is exactly like you said. You create a new array, you copy everything into it, and then you've got the space to add the next thing. So dynamic arrays are, they're just, you get them by default in Python and JavaScript. The other interesting data structure that you get here, which is the data structure everybody forgets about, but they're actually really useful, is something called a heap. And a heap is a really straightforward use for a data structure. A heap it allows me to get the biggest thing from my group, my data. So I add something to the heap, and the heap reorganizes itself in a way that allows me to always access the largest thing. And when I take the largest thing away from it, it reorganizes itself so that I have the next largest thing. So heaps for anytime I have to think about priority, or I have to think about, what's the next most important job that I have to execute, anything like that. Heaps can be really useful, and they're efficient. I think that's the nice thing about a heap, is that adding something it's a little bit more than it's a little bit less than a big O of n operation. It's a log n operation, and at some point we can kind of go over how that works and how things move around. But ultimately, a heap works pretty well. Adding to it is log of n, taking off of it is log of n, which is much smaller. That's good. That's not as good as big O of 1. Like, it's not as good as constant time, but it's still pretty good.
It's better than O of n.
If you can get log of n, you're probably in good shape for most things. Even if you can get n log n, which is like log of n times n, is still pretty good. So if you had to take everything off of a heap, if you think about that, if taking one thing off is log n and taking n things off, so n log n is how that works. So even that's pretty good. Most things that are, if you're not dealing with a ton of data, and a ton, I mean by like billions of things, n log n is probably going to be a pretty reasonable operation.
Okay.
So, and then hash tables also use arrays, and hash tables are like this weird, mysterious foreign language that seems kind of like magic that you just have to trust it works. And then eventually you have this aha moment. You're like, oh yeah, it finally makes sense. But it took me a long time to get hash tables. You kind of have to trust math. Like, you have to trust the fundamental nature of math for it to really click for you.
I need to build a better relationship with math, and that is not my strong subject.
Well, it turns out you don't really need to understand the math. You just have to trust math. So, you're probably okay for the way that a hash table works. We'll get to it. If we do a couple more of these, hash tables will be coming up. All right. So one of the things that we do is when we build a data structure is built for a particular purpose. And typically we encapsulate it. So we allow the outside world to do certain operations to it, but we don't let them access the data inside of it. So in JavaScript objects, generally speaking, the values in your object can just be accessed. But in a lot of languages, if we were writing the JavaScript language and we wanted to introduce an object, we'd probably want to encapsulate it so that nobody can mess with our data directly. So if you think about a stack, you really only want people to take things from the end, and you want people to add things at the end, and you don't want them mucking around with anything in the middle. Right. So by encapsulating, you can have a push, like you can define a push operation, a push method that will allow you to add data to it. You can define a pop and a peek operation that will allow them to take the things off or view the things. But you control all of the implementation. Nobody sees what you've done inside of this. So by doing this, if you keep track of the last, then you can just add, when you call push, you add an item to whatever your last is, and then you increase your last. So you always add to where that next empty space is. Now, if you're using an array, eventually you may have to make it bigger. That's part of the operations. We may have to do exactly like you said, create a new array, copy everything into it, and then we have that new space. But that's basically how a stack works in practice. And then for a queue, you're doing kind of the same thing. With a queue, you can do a simple version where you are always growing your array as you move on, but that uses up more and more space. So one thing that we could take a look at is how do you build a circular queue where when you get to the end of that array, if you've moved past it in the beginning, you add things onto the end and you move that start further and further, and then your end, you move the end closer and closer to that. you can go back to the beginning by just saying, I got more space in the front, so I'm going to keep moving. So, that we call that a circular queue because you're kind of always moving in a circle. When you get to the end, you go back to the beginning. You get to the end, you move back to the beginning.
Does that mean I have limited space? Because won't I be overriding at one point?
So there are sometimes you want to do it that way. There are sometimes you want to have limited space and you don't want anybody to, to add more values to the queue than necessary. But that's not typical, of what you would want to do. You'd probably want to grow the size of your queue. So just like you have with your stack, when you have a queue, you would want to grow it. But, because the ordering gets weird, right? Like if I have my start is like at position 7 and my end is like at position 5, I can't just copy it directly over because I'll run into this situation where I have all this empty space or all these like weird empty spaces or like the space in between the start and the end. So you have to be a little smarter about how you copy it, but it's not, basically you're just all of the things at the end of the array I copy into a new array, and then all the things at the beginning of the array I copy into a new array, and then I start from there. So it works, and that allows you to be a little bit more complex and allows you to take more advantage of what you're actually building there without having to recopy everything every time. It gives you a little bit of capability on both sides of that. And then a dynamic array like you have in JavaScript, this is actually probably simpler than your queue because you're adding data, so we have a last. This last would say, what's the last thing that I have in my list, or what's another way you might see this referred to as next. So I might start off with next as 0, where I put the next thing in at 0, and then I add 1 to next, and then I put the next thing at 1, and when my next gets to the end of the array, that's where I have to do, like you said, I have to copy everything and I have to create a new array. And then a heap kind of works the same way. We have that last element, but like I said, it's a little bit more complicated. What we actually do is anytime we add to the heap, we kind of move it into the right place of the heap by looking at different values. And a heap is a really interesting structure when you get to it because it kind of looks like a tree, but it's all built in one single, linear array. But it allows you to do some really cool, efficient things pretty well. So heaps are an interesting data structure that, it kind of is clever the way that they operate. So it's an interesting one to get into. So that's a lot of data structures based on arrays here. That, some of this was surface level, but hopefully it was useful. Hopefully there were some informative things here.
Yeah, this makes sense to me. I just have to digest it because I haven't done programming for a while. I was like, this has been a terrible experience for me. I don't want to program. And then I went to front-end development. I was like, oh crap, like I might not need to learn data structures now because what if I go in a technical interview, they're like, how do you solve this problem? I can't be like, I don't know.
Yeah, well, and this is where they're going to come in, like understanding how the data structures operate and how to use code efficiently. That's going to be a lot of interviews, and it's not all of them. There's coding where you're taking APIs and you're connecting them to other APIs, and there's a lot of need for that. There's a lot of space for I understand how an API works, I understand how a framework works, and I want to connect these together, and I want to build software this way. There's also a space for I really want to engineer new things. I want to, I don't want to use the API. I have to do something that's never been done before, so I need to understand the data structure so I can solve these new problems. I think that the field is evolving where there's plenty of space on both sides of that. But I think that the best engineers understand how to leverage the API and the framework and everything, as well as how to solve these problems so that they can kind of put those together. And that's, I think a space that's worth working on.
Yes, like that's why I'm definitely here. I was like, let me show up on time. I'm back in summertime. I want to learn this. Thank you so much for taking the time to show me this.
Yeah, no problem. If you want to talk again, we could go over how to build a queue and kind of see how that circular queue works. We could go over, hash tables. We could go over heaps. We can go over anything you like.
Yes, I would love, if you have the time, I would love to actually get into coding. I'm talking about you gotta talk to me like I'm 5 basically, because I write a bit of code, but I tried solving some data structure problems. I was like, I don't know what this is.
I think you probably do better than you give yourself credit for here. So we'll definitely keep it up, and maybe we'll schedule something for next week.
Yeah, that sounds great. Please keep in touch.
Excellent. All right, we'll chat. Sounds good. Thanks.